Fairbanks Focus is a locally produced public affairs program created in part by University of Alaska Fairbanks, KTVF, and Fairbanks Economic Development Corporation.
Thanks for joining us again here at Fairbanks Focus Alaska View. I'm Nanette Pearson, and today I'm joined by Rajiv Ganguly, Director of Mineral Research Lab at the UAF up at the University of Alaska, Fairbanks.
That's great. Thank you for having me.
Thanks for coming today. And we're having you on today to talk a little bit about mining process and how sort of we get these minerals from the ground into our hands, but also a little bit about the education behind it too. Can we start with just sort of how that works?
Absolutely. The first part in this whole process is exploration. First you have to locate what you're interested in locating. So that's the prospecting exploration side. Then, in the case of certainly modern mines, follows a lengthy process of development where you take your deposit and you define ways you will extract and process the deposit and do it in an environmentally safe manner, in a manner that is safe to the public, and obviously it has to be economic as well. It has to meet all the regulatory requirements. So that is a lengthy multi-year process, and usually the time between find to the mine could be anywhere from 5 to 70, 80, 90 years in the case of some deposits. Then comes the extraction part, where you actually do the extraction, you break, you get the rock, and during the same time, of course, you're also doing processing, which can be very, very complicated. And in some processes, like in the case of gold, you're pretty much near the end line at the mine site itself. But in some cases, it has to go further downstream to further metallurgical processes before the product is ready for the jeweler. So it's a long process and very complicated, and each aspect requiring a different set of expertise. Prospecting side, it's geology; mining side, it's mining engineering. The mineral processing is heavily chemistry focused. And so downstream processes are all chemistry, chemical engineering.
Well, and you're a mining engineer, and you're
correct.
professor for the mining engineering department. And I know that you are pretty involved and know a lot about the things that are happening at the collegiate level and at the learning level for people as far as working in the mining industry. So what would you say are what's the future of mining in the state of Alaska?
The future is really good. We are very, very blessed. But the future will not come to us. We have to take it. So we have what can be given to us. We already have. We have incredible resources. It's unbelievable. 15% of the world's coal. We have a mine here, a zinc mine, the world's largest zinc mine. We have a tremendous amount of copper and gold. But that will not automatically go into your iPhones. More than jewelry, it's probably the iPhone, your car that uses your deposits. That's what we need them for. So, but to do that, we have to successfully mine them. We have to successfully permit them. Permitting is a big challenge on both sides. First, you have to find good engineering solutions. Then you have to have a large number of people that are technically competent on the state side, on the government side. People don't talk about that. And so you need to also ensure that the government has enough technical people to deal with these complex documents. Then during the extraction phase, you need to provide staffing. And anybody will tell you that staffing a large mine is difficult in and of itself. Finding mineral processors is such a difficult job for every location. In Alaska, then you have the Alaska factor that is incredibly difficult. So yeah, to me, I'm really excited about what we have. I'm really scared about what we need to do for us to take advantage of the mineral resources.
Well, and I know that there's always the problem too that there's a limited number of people doing things like processing and permits, and there's such a limited number of people working in the industry that sometimes you have to make sure that you're not doing things like interests, like, if someone's got an interest in this mine, that they're not the same people who are writing the permits, and that turns into a problem too.
That is correct. And that is why it is very important that you have a well-funded, a strong academic and government program with the people that have the same type of technical skills in engineering, in mineral processing, that can evaluate, look at a project and say, what you're proposing is reasonable, it can be done. Mineral processing is actually what determines your downstream, or many of the downstream environmental impacts, because the chemistry happens, the chemicals happen. A lot of the chemicals that people get upset about happen in the mineral processing state. So you want to say, I want to mine responsibility. You have to provide really good mineral processors and that can come up with mineral processing strategies that are the most benign.
Well, and they're the gatekeepers for safety.
Absolutely, they are. And so safety starts from geology to mining to processing. The whole chain, safety is absolutely critical.
Well, and the processors is where you're saying before, that's where we're really just lacking the most. Now, I know we were talking before about different colleges and different places that offer things like mining engineer degrees and processing engineer degrees and things of that nature, but there's very few of them in the world.
That is correct. We only have 14 accredited mining engineering programs in the country. We have 13 geological engineering programs. What does that mean? Well, we have 500 geology programs in the country, and we have, maybe 1,000 English language programs, just to give you a scope of how few people there are in this business. We graduate maybe 300 mining engineers a year in the United States, and about maybe 12,000 civil engineers in the country per year. So just to give you a scope. So many of the programs have disappeared over the past 20-25 years. We've been doing mining here. The University of Alaska, very few people know, started off as a mining school.
Yeah.
So we are the mining, Brian Rogers might say we are, a university. I like to call us the mining university of the state, So we are the only ones that do the engineering side of mining. We are the only one in cold climate in all of North America. This is our specialization. We have great Arctic engineering expertise. We have a strong geology program. It's amazing how strong the geology program here is. So we have a nice suite of expertise, and anytime we want to leverage that, we can. It's just willpower. So.
Well, I know that you're saying that we should really be looking too at sort of fostering a homegrown movement as well as working internationally.
That is correct. We have, for our deposits, we have to mine them. These have to be mined and processed by Alaskan kids, because they are very unlikely to be wanting to move the day they get their job, okay? So we have to do that. And you see that in turnover. Some of the mines have had turnovers of 30-40%. That you cannot survive as a business to do that, okay?
No, because the cost of retraining all of those people.
That is correct. That is correct. And so we have to do that. Secondly, in the mineral processing side, and like in areas like ventilation, there's very few people. There's experts already that exist. Many of them are older, and we need to bring in new experts, and they're going to come through universities. And if the universities are gone, it's going to be difficult. We'll have to take a chemical engineer that does oil refining, turn him into a mineral processor if they decide to change industries, and then it's not going to be great because that's not their core expertise. We also have a lot of placer deposits. We don't talk about them. The placer deposit could also be serviced by a strong university. Mineral Industry Research Lab used to provide a service to placer miners, where yet placer miners would come in, they would bring their stuff, and we would look at them and say what they could do to get more gold out. Well, we cannot do that. We don't have the staff to do that. So to me, a strong university is good for the placer miners. Strong university and education system is good for the sector in general. So.
Well, and good for industry in the United States. Would you say that we're losing industry in the U.S. by not having processors, but not having these educated people?
Yes. We cannot permit many types of mines in the country. We don't have the people skills. I think I heard recently that Yukon is now going to import miners from China, okay? Because they cannot do mining. They realize you can do mining, but they don't have the people to do it. I'd hate to see that. We have lots of kids that have the knowledge. They have, a lot of the native lands. These kids that understand a lot of the physics and the chemistry intuitively. I'd like them to be in charge of our deposits.
Well, absolutely. It'd be nice if we could have, like you said, that homegrown part of people in Alaska working in the Alaskan industries, and the idea that you would ship people in from another country to do work just because there's an under representative people in the area. That's just heartbreaking.
Yeah. Alaska has a very good educational tax credit system. Sumitomo and Kinross took advantage of that, and they support the university educational mission in mining engineering. I'm hoping Tech and Hecla, all of these companies realize as well what the university can do, and we are hoping we'll see support from them as well, supporting the mining engineering programs, the mineral processing programs that will eventually support their own projects.
Definitely, and I know you said the university is really trying to step it up and bring younger people into mining engineering and into the process, especially into processing of these metals and various things for mining. What are people working at all, or is the university working at all to get people younger interested? Because the sooner you can plant those seeds, of course. You talk to a small kid about what do you want to do, and well, I want to mine, or I want to be a mining engineer, or I don't hear a lot of kids talking about wanting to process minerals. And I know when I was a kid, that had a huge impact when someone came to my school and was like, these are all the super awesome things that you get to do. So what would you say to kids out there, and does the university have anything in place like that?
The mining industry suffers from image. It's partly our problem. A lot of mines do a great job mining. They don't want to talk about it because mining sector in general does not like attention. So you have great work. Greens Creek has been mining inside a national monument for 30 years? But you won't hear Greens Creek bragging about that, okay? So kids don't know, so nobody wants to be a mining engineer or a mineral processing engineer, and that's the truth. I go to high schools, they want to be astronauts, but I have to, when I go to talk about mining, I end up defending mining rather than what mining can do for them as a career. And so unfortunately that's the case, and I'm hoping...
Well, and I don't want you to defend it here, but what would you say is like some of the really cool, fun stuff, like if you're talking to a bunch of high school kids about that you get to do as a mining engineer?
Hey, blow up 5,000 tons of explosives. I offer that. Spend 4 years with me, and you can blast away. You will have the pleasure of knowing that the person that is sending you nasty emails or is upset about what you do is using your product. Your product is what is allowing them to complain about you. So that's great. You're enabling when they drive to the protest to protest your job. They're doing that on stuff you made possible. And so you're supporting entire civilization. And that's a great feeling.
Well, and I know we were saying a little bit about, so really, anymore, we forget that so much of these metals and things, a lot of it does go into jewelry, but even more of it goes into things like your cell phone, your iPad, and your computer.
Technology, medicine. Think about this. There's an artist creating pottery, okay, using light and heat, okay. There's a metal artist doing painting using colors. Okay? You made all that possible. So the pottery, the artist may come and protest. That's fine. Protests are what keeps us honest as well as an industry. So, but you're supporting. So the value of mining is not the revenue we got from tax. It is us allowing the artist to produce art. It is us allowing the doctors to do surgery. And this is where I take a fault with the mining industry. They always describe the value of mining in dollar terms, and we are short selling, okay? Mining is not about the dollars or the tax revenue. Mining is about us allowing the lifestyle we have, about the artists, about the music. Can you imagine all the musical instruments, the metal consumption in them? think about the pleasure the iPhone brings you. So that's what this is about. And to high school kids, I would like you to be part of that, to allow us, you know, as humanity, to enjoy those things. So.
Awesome. Well, thank you again so much for coming on today, Rajiv. We really appreciate having you. And that's going to do it for us for this segment here at Fairbanks Focus Alaska View. And we'll see you again. Welcome back to Fairbanks Focus Alaska View. I'm Nanette Pearson, and I'm also joined today by Tim Staten of Alaska Golden Gems. Hi, Tim.
Hi, how you doing?
Good. How are you?
Good. I appreciate you asking me on.
I'm really glad to have you. I was thrilled with getting my ring sized and cleaned as a Fairbanks First member.
Thank you. You know, I watched the first segment, and I think this is a great entry into the second part because it's very well tied to mining and what Rajiv was talking about.
Well, and you were saying that you really started in the jewelry business as a placer miner.
I started. I came up here in 1978 to mine gold and mined for 4 years, and during that time we got large gold nuggets. The largest ones were 7 3/4 ounce, and all the rest of them in the meantime, in the winter when we couldn't do anything, we turned it into jewelry. And of all things, you know, Rajiv had talked about school and how you need to learn as much as you can. Well, I was a mechanic and a welder, but I had 3 years of jewelry arts in high school.
Oh.
And so by 23, I was making jewelry in a whole field that I'd never expected to be in. And now here I am 24 years in my store, the 15th. And, you know, that's quite an accomplishment, just going from a miner to a jeweler, except for I just look at it as I just shrunk inches down to millimeters when I was cutting things, and so it was actually pretty cool.
Oh, very cool. Yeah. Well, and I love your shop, and I know that mining is really just sort of, or not mining, jewelry making is really advancing along with technology.
It is, and you know, for the jewelry industry, I mean, for the most part, most of the jewelers in town, and if not all, are professionals. They've spent many years honing their craft as jewelers. In the beginning, I used to carve waxes like this. It would be carved out of wax from a block of wax. And the technology in the last 15 years has changed so drastically, and I've been doing this for 10 years now. But I use a CAD program to actually design jewelry and make CAD designs that these waxes are all from, actually. And everybody's heard of lately the 3D growing machines and the
3D printers.
3D printers and things like that. Well, this is coming from a whole industry that had already been out there but was just too expensive to use. And now it's gotten to the point where a jeweler like myself can actually take a CAD program and make anything I want out of wax. And there's two different ways to do it. It's called additive and subtractive. Subtractive is when you take a couple waxes or a piece of wax and a mill and it cuts the wax out for you. And that's the subtractive, and then the additive is where it actually grows. It grows from the bottom up and turns into a ring like that. And all of a sudden you have a ring. It's a little more complicated than that. It's like laser jet technology, spraying back and forth layers of polymer with light shining on it and making it solid, and it grows from the bottom up and makes any item that you've designed in CAD. So that's what I've been doing for 10 years.
Well, and once you have the wax.
Once you have the wax, you can take the wax, and then again in my store I cast gold and silver. And so I didn't bring anything to explain how casting works, but this wax is basically put into a can. It's held into a plaster of Paris-like material called investment. It's turned upside down in a kiln, burned out at 1200 degrees, and leaves this hole inside there. We put that in a centrifugal like casting machine, right? And it's called a broken arm casting machine. And as you heat the metal up, it becomes like mercury. And you drop the pin, and it slides out and throws it out like that. And the centrifugal force forces the metal into the hole.
Oh, cool.
Basically, and you come up with the ring, like this.
Oh, very cool. And I love the detail on this. Now, were you able to do that kind of detail previously before working with these kinds of programs?
No. I mean, there were some people that could possibly do that, but even this little ring here would take probably, I don't know, 5 to 10 hours to get it exactly like this, because the braiding detail, and we probably wouldn't do it the same way. I would take that back. It'd probably take about an hour to carve this wax, because what we would do then is in the metal, we would weave what metal, and then weld it to the metal from the wire. We'd weave wire and weave it into the groove, and then bring it around and solder it in place. Whereas this is actually cut out with actually a four-axis milling machine. The original wax was, and then I cast it in my casting machine in white gold. Yeah, so it's pretty cool.
That's a really cool process, and I guess I didn't ever realize how truly involved it was.
It is.
Tell me a little bit more. Now, you said that you work with the AutoCAD programs too.
It's not an AutoCAD. It's called Rhino.
Okay.
I have 2 different programs. One program is with the public. They can come in and we can sit down and we can sit in front of a screen and pull up all different types of items, and we can modify them to a certain extent. And then the customer has thousands of rings to choose from, thousands of styles and different models. And we can add stones, we can shape the different shape of the stones, the color of the stones. It's all changeable. It's all rendered right in front of you, so it looks like a real ring at the time you're doing it. But that's limited. In the back, where I sit most of the time working on my computer, is where I design actual programs. And I made a video.
Okay.
And if he can show that video, I can kind of explain how that went.
Yeah, absolutely. Tell us about working in this program.
With this video, you'll see is a picture that is turning around and around, and you'll see where I've put in some lines we call curves and profiles. Added we flowed this curve and profile, made a solid side out of it. I've turned it around and made 2 sides out of it. Then I add stones to the sides and cut out the grooves. And then I've actually made a solid model through this CAD program. And at the end of the video, you'll see where it is turning into a render. So then I can show what the actual item would look like. And it looks like a real ring. And there's several pieces of clips or pictures that I brought with me, so that you could kind of get an idea. Some are renders, and you'll see the one with the Valley State Bank, which is a wax. That one there is a picture of the final product, and we did some award rings. So we can do awards, we can take logos, we can do animals, organics. It's called organic modeling. We can organically model. We can do fingerprints. We can take your fingerprint and make a ring out of it, or a pair of earrings for your thumbprint. You can do a family fingerprint ring. It's crazy. I mean, it's just crazy what you can do.
Well, that's really cool to know that, I mean, not only can you come and, buy or find the perfect engagement ring or what have you, but you can come in and actually design the perfect engagement ring instead, or whatever it is. It's your mom's birthday, like you said, the fingerprint ring. I'd never even thought of such a thing.
Yeah, and the thing about this is there's 2 different ways to do this. You can make a mold of the original, and then repeat that again. So if I want to make different things, and then you can make a metal mold, which is even more precise, to repeat things for like pins and things like that that are made for awards and
something that you're going to make
over and over and over and over. Right. So it's pretty cool stuff.
Well, and I really want people to know where you're located.
Oh, I'm on 2nd Avenue. I'm right between Soapy Smith's and Ann's Beads and things. I've been there for 24 years, across from the Marriott. Yeah. And I brought a little photograph of it just to show you.
And I really like your logo with the big black sign and the Aurora in the background.
Thank you.
It's nice.
I just put up a new logo. I'm working on cards for this logo, but I think they're going to show that on there too. And I brought a few other items in pictures that you could probably notice some, really interesting designs.
Well, and I was really impressed when I was there. It's kind of one of those things, 2nd Avenue is a crowded spot. There's lots of stuff going on. It's a busy place, and it's fun to walk around. And I was just blown away by some of the work he had in there. It was just like, oh, cool. So it's nice to check that out and to see it.
Yeah.
So.
And I mean, like you came in to have a ring size. They do that, of course. Yeah. Obviously, I sit at the bench and do everything there at the store. It's, just me. So I'm pretty busy most of the time. And I keep busy, especially with designing and making. People come in and say, well, what have you made? Can you show me what you've made? And I take them to the computer now instead of to the case, because I don't get enough time to make things for the cases as much as I can show you what I just made. The customer picked it up. Sorry. But you can bring a picture in. I won't exactly copy something. It's just not what I do.
Right.
And what I want to do is I want to say, okay, this is your concept. Let's make it your own. Okay? Do you really want that? Because, I mean, like 10,000 people have that on their internet, and they're probably wearing it. So why don't we take the concept and make it yours?
Well, and especially with jewelry, because it can be such a personal thing.
Yeah.
The idea to be able to personalize it
exactly
is really cool. And the fact that we live in the modern age where that's like not really a big problem or a deal anymore.
No,
it's like, oh, sure.
It's amazing what you can do with this program.
Yeah.
With these programs that I like I say, I've been doing it for 10 years, and I think my brain's full, but I'm still trying to learn more.
Well, there's always room to learn more.
Yeah, but that's where stuff gets pushed out the backside. That's the things that you don't remember. That's why as you get older, yes.
You start to remember.
Yes, things drop off, and because you're putting new stuff, it's full. It's like a hard drive.
So, where do you, just out of curiosity too, because we were talking about mining before, where do you get your gold and your minerals?
Well, I buy gold in the raw form, and of course we buy gold nuggets from miners when we have a chance. But the price of gold now, and there's another thing, a little anomaly with gold nuggets is that it's not as popular as it used to be because the white metals have taken over, and yellow metal is not, the primary metal. But Fairbanks in Alaska itself is known for gold nugget jewelry, and obviously, I'm more than willing to make anything in gold nugget, and I have lots of molds to do that with, a limited amount of jewelry in the case itself. But yeah, that's gold is king. You know who makes the rules, right? The golden rule.
Oh yeah.
Yes, it's the guy with the gold. So
well, cool.
Yeah.
Well, that's gonna just about do it for us. I want to thank you again for coming on today.
Thank you.
And I also want to just remind our viewers out there that you are a Fairbanks First member. If you have rings that need resizing and you're a Fairbanks First member too, you can bring them on down.
Yes.
Have them check them out for you. And like I said, I was just thrilled. So I thought that it was like, oh, it's so pretty. I forgot that my ring was that beautiful. So so I appreciate that.
Thank you.
And well, that about do it for us here at Fairbanks Focus Alaska View. Join us next week.